Our next unit, which is on electricity and circuits. We're going to start by reviewing Coulomb's law and then the elementary charge, and then we're going to go ahead and do questions that involve those two things. So Coulomb's law is the force between two charges, denoted as Fe. It's calculated by Coulomb's constant K multiplied by the first charge multiplied by the second charge divided by the distance between those two charges squared. Your Coulomb's constant is always going to be 9 times 10 to the power of 9. The units are newtons times meters squared divided by Coulomb squared. The other thing I'm going to review about is the elementary charge, which has a magnitude of 1.6 times 10 to the power of negative 19 coulombs. If we're looking at the proton, it'd be positive 1.6 times 10 to the power of 19 coulombs as its charge. If we're looking at the electron, it's going to be negative 1.6 times 10 to the power of 19 coulombs. So we're going to go ahead and apply this to example 1 right away. There are two charges of 8.5 times 10 to the power of negative 9. Each are separated by 0.05 meters. You want to find the force they exert on each other. And then we're going to look at the scenario if one is positive and the other is negative. You want to find the direction of that force. So to find the force between those two charges, I'm going to use the formula that we have just above. K is 9 times 10 to the power of 9, which is your Coulomb's constant. We're going to multiply this by our charge of 8.5 times 10 to the power of negative 9 coulombs. And the second charge has the same charge. So I'm just going to square this for simplicity. And then we'll divide it by the distance between the two squared. So if you go ahead and plug this into your calculator, you should get 0.00026 newtons. Or if you want to write this into scientific notation, that's 2.6 times 10 to the power of negative 4 newtons. Now the last part of the question asks, what is the direction of the force if one charge was positive and the other charge was negative? Well, we know that if we have two opposite charges, they are attracted to each other. So it looks like they're going to be going towards each other because they are attracted to each other, since one is positive and the other is negative. So we'll just state the direction of the force is just towards each other. Let's look at our next example. 3 charges are shown in the line below. Find the force on the middle charge, and that middle charge is B. So go ahead and draw this diagram and then we'll begin. So if I want to find the force on the middle charge, which is B, I need to find the force between B and A and also the force between B and C. So I'm going to say that the first calculation I make is the force between A and B. The second calculation will be from B to C. Then afterwards, I can find the force, total force, being applied for B. So between A and B, I'm going to write down my formulas for this. We have our Coulomb's constant, the charge of A multiplied by the charge of B, divided by the distance between A and B, squared. So the Coulomb's constant is 9 times 10 to the power of 9. I'm just going to leave out the units for simplicity. Now, be careful with writing in your charges because in this case, it says microcoulombs. 1 microcoulomb is equal to 1 times 10 to the power of negative 6 coulombs. And we have to do our calculations all in coulombs. So I do need to make that conversion. If I have 4 microcoulombs, this means that I have 4 times 10 to the power of negative 6 coulombs. And then for B, I'm going to ignore the negative for now because I'm going to show the direction at the very, very end. So I'm just going to say that this is 3 times 10 to the power of negative 6 coulombs once I do the conversion between microcoulombs and coulombs. Again, I'm just leaving that negative out for now because it will tell us the direction for the total force, but I can always just figure that out at the very end. Now I'm going to insert the distance between A and B, which is 45 centimeters. I do need to make that conversion into meters. So I'm going to divide 45 by 100, which is 0.45, and then it'll be in meters. So I'm going to put this into the calculator and see what we get here. We should get 0.53 newtons. Now for our direction, B is negative, A is positive. So a positive charge and a negative charge, they're going to attract each other. If I think about my direction, because everything's with respect to B, I'm going to say that B would want to move towards A because opposites attract. And that would be our direction. And also because it's moving to the left, if it's going towards A, the other way I can say it is negative 0.53 newtons. Instead of saying towards A, I can just put the negative in the front. Moving on to finding the force between B and C, I'm going to use the same sort of formula, but now we're looking at the charge of B multiplied by the charge of C divided by the distance between B and C squared. So for our charge of B, we have negative 3 microcoulombs. Again, I'm going to leave the negative out for now and then look at our sign at the very end. Microcoulombs is going to change into 10 to the negative 6 coulombs. And then for QC, that's 5 times 10 to the negative 6 coulombs once I do the conversions between microcoulombs to coulombs. Then lastly, the distance between B and C is 55 centimeters, but in meters, it would be 0.55. So multiplying this together and dividing by 0.55 squared, we get 0.45 newtons. Now we'll think about our direction. From B, we have a negative charge. C is a positive charge, so B will be attracted to C. And our frame of reference is on B, so B will move towards C because they are attracted to each other since they are opposites. And if I want to indicate the direction instead of saying towards C, since we're moving to the right, this would become positive 0.45 newtons. Now the last thing we're going to do is calculate our total force acting upon B, being influenced by A and C. So it's going to be the sum of the force of A to B plus the force from B to C. Well, we found the force of A to B is negative 0.53, and the force between BC is 0.45. So our total is negative 0.08 newtons, or you could also say 0.08 newtons to the left because it's negative. And that is our final answer. In the next example, we're going to write the same information down as before, but instead we're going to find the forces acting upon C. So I'm going to quickly draw this again. The distance between A and B is 45 centimeters. Distance between B and C is 55 centimeters. Okay, so kind of just like before, I have to consider the force between A and C, and also between B and C. So those are the two things I'm going to find first before I find the force on C. So looking at the force C to B, we're going to get the same thing as up here. So I'm just going to write this down right away. I guess to refer back to example 2. But force BC, the magnitude is going to be the same. It's going to be 0.45. I'll just say refer to example 2 because we already did this calculation. And now my frame of reference is from C. So we're looking from C to B. And they will attract each other because B is negative and C is positive. So this would be going towards B. Which is this direction here. And it's also going to the left, so this would be a negative. Now looking at the force from C to A, we're going to have to do this calculation because we don't have this yet. So the charge on C is 5 times 10 to the power of negative 6 coulombs. Again, remember to do your conversions between microcoulombs and coulombs. QA is 4 times 10 to the negative 6 coulombs, all divided by 45 plus 55 centimeters. This is 100 centimeters, or in total that's 1 meter. Now we're going to do this calculation. This is 0.18 newtons. Now we're going to figure out the direction. So C and A, they're both positive charges, and two charges that are like to repel each other. So we know that's going to repel, which means instead of we're from going towards A, we're going to go the other direction away from A. And because if it's away from A, it's going towards the right, this will be positive 0.18 newtons. Now we'll look at the force on C, which is going to be FCB plus FCA. So FCB was negative 0.45 newtons, FCA is 0.18 newtons. If you add those together, that's negative 0.27 newtons. Or you could say 0.27 newtons to the left. The last example we're going to do is a different question altogether. Please draw down this diagram and then we'll get started. So for example 4, we want to find the point on the line that the net force between the charges equal to 0. And we've been given the 3 different charges. We don't really know the distance between A to C and C to B. There's indicated by 2 minus x from A to C and just x from C to B. So we probably want to find what x is, because this will help us determine at what point on the line is the net force between the charges equal to 0. So if the net force between the two charges equal to 0, that means that if I were to sum up from the force from A to B, A to C, and from C to B is going to be 0. So if I kind of just rearrange this, the magnitude between these two would be the same if that were to occur. So this is what we're going to use to solve for x. So from here, I'm going to change FAC to the formula for it, which is K QA QC over RAC squared, and do the same thing for FCB. Before we go ahead and fill this information in, I'm going to make some cancellations to simplify our calculation. So as you can see, we could divide both sides by K and cancel that out. We could also divide both sides by QC since they're on both sides, and that would also cancel out as well. So on our left hand side then, all we need to consider is QA over RAC squared. So QA is 4.5 times 10 to the negative 6 coulombs. The distance between A and C is indicated as 2 minus x. QB is 8.5 times 10 to the negative 6 coulombs, and the distance between C and B is indicated as x. So since we have a fraction equals a fraction, I'm going to cross multiply and divide to simplify this. So you're going to have 4.5 times 10 to the negative 6 coulombs multiplied by x squared. I'll leave the units out for now, just to simplify things a bit more. And then on the other side of our equal sign, we have 8.5 times 10 to the negative 6 multiplied by 2 minus x squared. Then my next step is to simplify the right-hand side. I'm going to expand 2 minus x squared, which is 4 minus 4x plus x squared. And then I'm going to multiply this out. And this is what we're going to get when we do this. Now I hope you can see that we have a quadratic going on right here. This is our constant term. Then we have another term with just x, and then another term with x squared there. So when you solve for something like this, you're going to move everything to one side of the equal sign. So on our other side of the equal sign, it's just going to be 0. So that means I'm going to combine 4.5x to the negative 6x squared and this 8.5 times 10 to the negative 6x squared. I'm going to move it to this side. So 4.5, once you move to the other side, has become negative 4.5, which is just going to be 4. Now, we don't need to deal in scientific notation, so what we can do is multiply both sides by 10 to the power of 5, or 10 to the power of 6. So I'm just going to multiply both sides by 10 to the power of 6, and then we can get rid of some scientific notation here. So on our left-hand side, that's still 0. This is going to be 3.4 times 10, because if I multiply 10 to the negative 5 with 10 to the 6, we're going to combine the exponents, so that would be 10 to the power of 1. But in other words, that's going to be 34. And then for our next term, multiply that by 10 to the power of 6. We're going to get 3.4 times 10 to the power of 1x. If I simplify that again, that'd be 34x. Then the 10 and the negative 6 and the 10 to the power 6 will cancel out, so you have 4x squared. So this is what we're trying to solve now. To solve for x, we're going to use the quadratic formula here. So it'll look like 34 plus or minus 34 minus 34 squared minus 4. A is 4, C is 34, all over 2 times 4. So if you put this into your calculator and do those two things, you're going to get 1.1 meters and also 7.4 meters. Okay, but one of them is not going to work out. That's because if I were to insert the 7.4 in for this 2 minus x, we will get a negative. If you do 2 minus 7.4, you will get a negative number, so we cannot have that. We can't have a negative distance, so your only answer is going to be 1.1 meters. So your final answer is 1.1 meters for x.